Okay, so we're going to do practice E, projectiles launched at an angle. So the first thing we're going to do E2. E2 is a little bit more difficult than E1. So we're going to write our given. Now remember, on these types of problems, we always want to separate our x and y given. So I'm going to read the problem. It says a projectile is fired with a velocity of 196 meters per second at an angle of 60 degrees with the horizontal. So the first thing I want to do is I want to draw a picture. I'm going to draw a big dot to show where motion begins because that's my frame of reference. And I'm going to use my same standard Cartesian sign convention from that point that up and to the right is positive. So the velocity is going like this. This is VI, and this is 196. And then this is just showing you the initial velocity. It's going to end up going like this. This is going to be the path of the projectile. Okay. And they tell me that this angle here is 60 degrees. So that's all I have in my given. Now, when we talked about our given, we said the first thing that we're going to do is we're going to say on every single problem that AX is 0 and G is equal to negative 9.8 meters per second squared. We're going to do that on every single problem. So that's step one. Step two, I said if you're given your initial velocity, break it up into horizontal and vertical components. Now, when we did horizontal projectiles, the VIY was 0. VIY is not 0 here, is it? No. Okay. So the next step I'm going to do is I'm going to take my initial velocity, and if I want, I can draw it to the side because the more I write down on paper, the less likely I'll make a mistake. So VI is equal to 196, and I'm going to find the horizontal and vertical components of that. So this is where I start, and this is where I end. So first, I'm going to go horizontal. So this is VIX. From the head of this vector, I'm going to do the tail of the other. This is VIY. And this angle here is 60 degrees. So all I'm doing is redrawing this over here just so I can conceptualize it. Now, some of you feel like, well, I don't have to do this. You know, I already know how to do it, and everyone's different. So how do I know to use sine or cosine? Well, VIX is adjacent to the given angle. So adjacent is cosine because cosine of theta is adjacent over hypotenuse. If you don't know that, write it down. Cosine theta is adjacent over hypotenuse. So in this case, cosine of 60 is adjacent, VIX, over the hypotenuse, which is 196. So that's why a lot of times I go straight to the step of VIX is equal to 196 cosine of 60. Now, some of you are not putting this in your calculator. You don't multiply the 60 times 196. The 196 has to go in the front. So if I look at my calculator, I press 60 cosine times 196 equals, and it comes out to be 98 meters per second. So VIX is 98 meters per second. Now what I do is I can go ahead and put this in my given. VIX is 98 meters per second. So now I want to find VIY. Now I can write sine of theta is opposite of or hypotenuse, but at this point I should be able to say VIY is 196 sine of 60 because VIY is opposite the 60 degree angle. So this comes out to be 170 meters per second. And then I'm going to put that in here. VIY is equal to 170 meters per second. Now, the next thing I told you to do, step 3, is I said look at any other information they gave us in the problem. They didn't give us any other information. Okay? So at this point, we could also have some hidden variables. There's more than one way to do this problem. So first, I'm going to show you a way that I recommend you not do. And I'm going to show you why. So if this is where I start and this is where I end up, my vertical displacement, remember displacement from where I start to where I end up, y is equal to 0. So in part A, it asked me to find the time. So if I have little g, I have VIY, I have y, and I want to find time. And I worked a lot of the solutions this way because it's the way I'm used to doing it. If I did it this way, I would use the equation that y is equal to VIYT plus 1/2 GT squared. But VIY is not 0. So if I substitute in my value, 0 is equal to 170t plus 1/2 negative 9.8 t squared. I'm just going to show you I have a t and I have a t squared. How would I find that? I would have to use the quadratic equation. Now, how many of you want to use the quadratic equation to solve a physics problem? If you could avoid the quadratic, you can. So if you want to use the quadratic, go for it. Okay? But I'm going to show you an easier way to do it that we don't have to use the quadratic. All right? So sometimes in my solutions, I'm going to show it doing it this way. All right? But I'm going to show you a much, much easier math way to do it. All right? But the math way, you have to understand the physics. So this is my initial velocity. Now in projectile motion problems and throughout the whole course of this year, we're not going to take air resistance into consideration. So if this is my initial velocity, that means down here, my final velocity is also going to be 196. Now let's look at a picture in detail of my final velocity. This is my initial velocity. So my final velocity is going to be like this. This is 196. But if I draw the components of it, this is where I start. This is where I end up. So first I'm going to go this way. From the head of that vector, I draw the tail of the other. So this is VIY and this is VIX. Now we learned before that the horizontal component of the velocity is constant. Remember VIX, oh I'm sorry, this is VFY and this is VFX. Sorry. So the horizontal component of the velocity is constant. Remember I showed you that with the equations? So I know that VFX is equal to VIX, which would be 98. Now the difference with VFY is here's VIY and here's VFY. So VFY is going to be equal in magnitude. Remember, the word magnitude means how much, but it's going to be opposite in direction. VIY points up, VFY points down. So VFY is going to be negative 170. So now I'm going to say VFY is negative 170. If I have VFX, VFY, I have little g, and I want to find t. So the easier way to do this problem is, again, I have VFX, VFY, little g, and I want to find t. So I'm going to say which equation has those four variables. So that's the equation VFY is equal to VIY plus GT. Now I'm not going to plug in my values because that's how I'm going to make a mistake. I'm going to rearrange the equation to solve for the unknown in terms of the known. So VFY, and I'm just going to scooch this up, VFY minus VIY over G is equal to T. So negative 170 meters per second minus positive 170 over negative 9.8 meters per second squared. So when I do all this, the time comes out to be 34.7 seconds. So this is easier than using the quadratic. So I recommend for all your homework problems, when you're finding the time, to do it this way. So the physics that you have to know here is that the horizontal component of the velocity is constant, so Vfx is equal to Vix, and then Vfy is equal in magnitude but opposite in direction of VIY. That's what you need to know. All right, so that's part B. So now let's do part C. So part C says how far does it go? So from here to here, the horizontal displacement x is sometimes also called the range, kind of like in golf, like a driving range. Okay, so x is sometimes called the range. So how do I know what to do? So remember, I cannot mix up my x and y's. All right, so if I want to find x, I need to use stuff here. Now remember, time is scalar. So if I found the time on this side is 34.7, the time on both sides is 34.7. So I want to find x, I know t, I know Vix, and I know ax is 0. So my equation is x is equal to Vixt plus 1/2 axt squared. Now remember, ax is always 0, so that whole second term disappears. So x is going to be Vix, 98 meters per second, times the time, which is 34.7 seconds. So this comes out to be about 3,400 meters. It's like 3,400 point something. How do I know what to do? These are my 4 variables. So I say to myself, which equation has these 4 variables? And the problem solves itself. This is systematic step-by-step problem solving. Not, I don't know what to do, I don't know where to start. The more you write down on paper, the less likely you are to make a mistake. Okay? All right, now we're going to do part D. So for part D, I'm going to show you how to do it 2 ways. You see how to find the time we could have done it 2 ways using 2 different equations, but we didn't want to do the quadratic. I'm going to show you how to do part D 2 ways again. All right, part D says calculate the maximum height. So first of all, what are they talking about, the maximum height? The maximum height is up here. So first of all, the maximum height is going to occur in half the time it takes to go from here to here. So this maximum height here is going to be y. So when I calculate it, it should be positive, because remember, I'm measuring from the ground up. Okay? All right, so let's go back to the problem. So there's 2 ways I can do it. The first way I'm going to show you is if I found the time to go from here to here, if I cover this up, the maximum height y is going to occur in half that time. So what we can do is take the total time and divide it by 2 and do it that way. So that's the first way we're going to do it. Okay? So the first way we're going to do it is we're going to say, I want to find y, I have little g, I have VIY, and I can do half the time. So I can say y is equal to VIYT plus 1/2 GT squared, and I can use half the time. Now you have to be really careful with your signs. So I'm going to say y is equal to 170 times 17.35 is half the time, plus 1/2 negative 9.8 meters per second squared, times 17.35 squared. So doing it this way, I get y to be 1475. But then I'm going to show you how to do it another way. The other way is, okay, I'm going to look at my picture, and I'll just draw it here. So if this is my vector and it goes like this is half the time. So let's just forget about this. This is VI. At this point, at the peak, my final velocity looks like this. So if this is VF there, you see that VF is all what? Horizontal. It has no vertical. So at the peak, VFY is 0. Does everyone see it? Because it's all horizontal. So if I look at it this way, I can say, well, VFY is 0. I know VIY. I know G. I can find Y. So now I can use a different equation and say VFY squared is equal to VIY squared plus 2GY. I'll rearrange the equation to solve for the unknown in terms of the known. So VFY squared minus VIY squared over 2G is equal to Y. Now this is 0, so I'll just get rid of that. So it's going to be minus 170 meters per second squared divided by 2 times negative 9.8 meters per second squared. So the negative in the numerator and denominator cancel, so I get a positive value, and this also comes out to be 1475. So the reason it took so long for me to work this problem is in 2 parts I showed you how to do it 2 different ways. What is the way that you should do it? You should do it the best way that you understand it. And we're going to see a lot of times there can be more than one way to work a problem. So I did it this way, and I did it this way. You work it the way that you best understand. Does that make sense?